this video, let us study how to find the convolution of two continuous time signals, that's using the timeline method. So in my previous video, I had explained you about the convolution integral, like how to derive it. So you know that x of t convolution of h of t, that is equal to minus infinity to infinity x of tau h of t minus tau d tau. So another formula was minus infinity to infinity instead of x of tau. Now means we know that it is a commutative, it satisfies a commutative property. So we can also write this as x of t minus tau h of tau d tau. So here to find the convolution of these two signals, so now we have taken u of t minus 1 convolution, that is with e to the power of minus t u of t. So how to find the convolution of these two signals using the timeline method? So for that, first you have to find this x of tau, you have to find x of tau, then you have to find h of tau, first to find h of tau and then flip it, that is h of minus tau, then you have to do the time shifting. So finally you are going to get this h of t minus tau. Okay, after finding all this, now we will be plotting it on the tau axis, that is a time axis, and then we will try to find out the convolution of these two signals. So first let us find the x of tau here. So what I will do is, now I will consider this as x of t and I will consider this as h of t, because reversing this u of t minus 1 is very easy. So what generally we do is, we will be considering the easy signal, okay, that is for the shifting purpose. So now I have considered this as h of t, this as x of t. So now x of tau, that will be equal to e to the power of minus tau u of tau. You know that x of tau means only the t variable is changed here, that is I am changing t to tau. Next is h of tau. H of tau is nothing but u of tau minus 1. So now h of minus tau. H of minus tau is nothing but, you have to replace this tau by minus tau. Minus tau minus 1. Next you have h of minus tau plus t. Minus tau plus t. So here what we can do, we can write it as t minus tau minus 1. Okay, or you can also write this as u of minus tau minus 1 plus t. Okay, so this is my h of minus tau plus t. Next what we will do is, we will take the tau axis here. This is the tau axis. So first I will plot x of tau. X of tau is nothing but e to the power of minus tau u of tau. And you know this, what is this u of tau? It is nothing but, it is from 0 to infinity, right? This is u of tau. This is the time. This is u of tau. So it is from 0 to infinity. So here the tau is from 0 to infinity. So I will consider this 0 and it will be from infinity. And here I will write like this, right? So next is h of minus tau plus t. So this is u of minus tau minus 1 plus t. So you know u of minus tau plus 2. So what will be this on the time axis? It will be from minus infinity till 2. Right, minus infinity till 2. So similarly you can consider u of minus tau, and this one will be from minus infinity to t minus 1. So minus infinity to t minus 1. So I will consider for the first case here. Okay, so this is from minus infinity. This is till infinity. Okay, so now minus infinity till t minus 1. So first case I will be considering it as, so we will be having two cases here. So you can observe this. This t minus 1, it can be less than 0, or the t minus 1, it can be greater than 0. Here, we can have somewhere here. Right? So these are the two cases that we are going to consider, because we do not know what is the value. If it was like minus infinity to 2, then we were sure about this, right? It was 2. But here it is t minus 1. So I can have t minus 1 less than 0, or I can have t minus 1 greater than 0, right? So these are the two cases. Now for t minus 1 less than 0, what happens is, here see, in the convolution integral we are going to multiply x of tau and h of t minus tau. So this is your x of tau, this is your h of t minus tau. So if I multiply these two signals, we do not have any common area, right? We do not have any common area. So what happens? This multiplication will be 0 now. So for t minus 1 less than 0, your y of t will be equal to 0 because it is not overlapping. There is no overlapping region here when t minus 1 is less than 0. So now next case is t minus 1 greater than 0. So now I will extend here. So we can say that this is the common region, right? That is from 0 to t minus 1, we have the common region, because for after this what happens is, it will be 0. This particular is 0, but only the overlapping region is this one. So we will be considering our integral only from 0 to t minus 1. So for t minus 1 greater than 0, we have 0 to t minus 1. And what about x of tau? It is nothing but, we have already found it out. This, the value is 1. So 1 into, and what is this? It will be e to the power of minus t. So it is e to the power of minus tau, because this is your x of tau. Then this one will be your h of t minus tau. So if I solve this, it will be e to the power of minus tau minus, and here it will be t minus 1, 0. So this one will be equal to e to the power of minus t minus 1, and what will be this? Plus e to the power of 0. So it is 1, e to the power of 0 is 1, next minus t minus 1. Okay, so this is the value of y of t, that is for t minus 1 greater than 0. So now what happens? We can write y of t. Y of t, that is equal to 0, and here this value is 1 minus e to the power of minus t minus 1. This is when t minus 1 is less than 0. That means when t is less than 1, and this is when t is greater than 1. So this is the answer, that is for the convolution of these two signals. So y of t is equal to 0 for t less than 1. Y of t is equal to 1 minus e to the power of minus t minus 1 for t greater than 1. So if I draw this, okay, for t less than 1, it is obviously this is 0. For t greater than 1, what happens? For t greater than 1, this is 0, and when t tends to infinity, e to the power of minus infinity, this becomes 0. So the final value will be equal to 1. So it will be like this. Okay. So this is my y of t. So this is the final answer. So this is how the timeline method works. And you can also solve this same problem by considering this as h of t and this as x of t. And you will be arriving at the same answer.